In this video, we'll see about grouping in Kmap using SOP form. So in SOP form, we group the ones. We'll just plot the ones in this Kmaps and we'll group them. We'll see that how can we group the number of ones in a Kmap. So first, coming to this 4 variable Kmap, the variables are 4. So 2 to the power of n is nothing but total number of variables. So 2 to the power of 4 will be equal to 16. That means we have 16 cells in a Kmap. Now in the 16 cells, the maximum number of ones we can fill are 16. So if we fill the maximum number of ones in this Kmap, that can be grouped. So here if we have the 16 number of ones, that means the maximum number of ones where a 4 variable Kmap can have. If we have them, we can group this to be a single group and just check what are common here. So for this all 16 ones, do you have any common variable here? No, you don't have. So the answer for this will be equal to 1. Yes, now we'll see about 8 number of ones. How many possibilities do we have for 8 number of ones? In how many ways we can group? So in the first case, here we have 1, 2, 3, 4, 5, 6, 7 and 8. 8 number of ones. If we have these 8 number of ones, then I can group all this together. And one more form is this way. If I have here, I can group in this way. And also here, this way, and this, and just look over here. If you have 4 ones here and 4 ones here, by just making this 4 and this 4 completely 8 number of ones to be only one single group. Next, coming to here, if I have same the 4 number of ones and the 4 number of ones to the ending of this Kmap, I can make this complete Kmap to be having only one single group of 8 ones. So the solution for this group, we can write it as, for this complete 8 ones, just check for the common terms. Here for this 8 ones, nothing is common from this variable AB. Coming to C and D, you have C bar is common for this row and C bar is common for this row, whereas D and D bar you have, so only C bar is common. So for this, the solution will be C bar. Next, here can you guess, here you will be having an answer D, because out of this 8 ones, only D is common for this both, whereas here you don't have any common from A and B terms. So the minterm for this Kmap is C bar. The minterm for this Kmap is D. The minterm for this Kmap will be equal to C, whereas for this Kmap, the minterms will be equal to, here C and D nothing is common, but in this both you have A bar common. So for this, the minterm will be equal to A bar. Now here you again have B as common. In this you have A as common. Now here you have 4 ones here and you have 4 ones here. So we can consider this 4 ones and this 4 ones to be a single group, as they are at edge of a Kmap. So we can consider it to be a single group. So the rule is nothing but we can group the number of ones horizontally or vertically, no diagonal grouping. So there are 4 number of ones horizontally here and here. So we are just grouping it to be a single group. So for this, just check with this row and this row. Anyhow, for 4 columns you can't have a common term, so you have 2 rows here. From 2 rows you can have one literal as common, that is nothing but C bar D bar. Here you have C D bar. So the solution for this will be D bar. So now coming to this Kmap, we have 4 number of ones here in this column and this column, so we can group together. to be a single group, and for this group I can write a minterm to be, the common minterm will be a b bar a b bar. So b bar is common. This is the minterm for this Kmap. So if you just observe, by increasing the number of ones, my minterms, the literals in the minterms are been reducing. So when they are reduced, definitely my circuit will also be reduced, because the expression in the end expression, whatever you are reducing, that expression will be very small. If you get less number of literals in your minterms, so your complete output expression will be less. When your output expression is less, your circuit will be less. Circuit construction of your circuit is very small, then the propagation delay will also be small, and also the cost of that circuit will be less. So all these are the advantages. Next, here we'll see about fourth number of ones, because 2 to the power of 3, that was 8. Now 2 to the power of 2 equal to 4. Out of all these 8, I'll write the solution for any two Kmaps. One will go with this. For this, the common term will be equal to, for 4 ones the common is AB, and here we'll see about this. For this, the common term will be equal to, for this you don't have any common from this, but whereas in this row you have a common C and D. In this Kmap you will be having CD. In this Kmap you will be having C bar D. Okay, so these are the different possibilities, and also you have these are few more possibilities of 4 ones grouping as a single group. So if you have 4 ones over here, you can group this as a single group, and from this, the minterm you can write it as, from this 2 ones, I mean 4 ones, you have 2 rows and 2 columns. So from this 2, the common term is A bar, B bar, A bar B. From this both you have A bar as common. Then here from this both you have C as common. So A bar C will be the minterm for this Kmap. Now coming to this Kmap, you have 4 ones here. So from this both A bar is common, from this both C bar is common. So A bar C bar. This is the minterm for this Kmap. So same way you'll write for all these Kmaps. I'll write for this Kmap. You try for the rest. For this 4 ones you have A as common here. Then from here you have D. This will be the minterm for this Kmap. So in this way you can group the 4 number of ones. Grouping 2 number of ones. So here in this Kmap I have 2 ones here, and there is also other one here. So I total I have 3 ones. So I can't group 3 ones. I can group 16 ones, or 8 ones, or 4 ones, or 2 ones, or a single one. Only these are the ones I can group in a single group. So 3 I can definitely not group them. So I'll go with these 2 ones, where these 2 ones make a group, and this is the edge to the edge of a Kmap, and this is to other end of a Kmap. So this both can form a one group of 2 ones. So for this I can write a minterm to be, for first this green color group I get C bar D bar, here I have A bar B bar, A bar B. So the common term is A bar, and from this here I'll have C bar D bar. This is a minterm for this group, the green circled group. Then the other minterm for this blue circle group will be equal to, from this both ones which is common, A bar B bar. This is common, A bar B bar, and here you have C bar D bar, C D bar. So D bar is common from here. So this will be D bar. This is the solution for this Kmap. So you need to group in this form. The other form you can group here. You have many number of ways over here, so you can try for 1 or 2 Kmaps, then you will have an idea how to group the two number of ones. So if you have 2 ones here, you can group here this one. Example, that is here, so I can group this and this to be a single 2 ones group. And the solution for this will be, first for this green colored group, I have A bar B bar as common. A bar B bar, from here I get C bar, plus next for the other group I get C bar D bar is common from this row. What about the 2 columns? I have B bar as common, so B bar C bar D bar. This will be the solution for this Kmap. So now same goes with this Kmap also. Just try to solve it by yourself. We'll see about this Kmap. Here I don't have any 3 ones in this Kmap. I have only 2 ones, that also to this corner and to this corner. So I can group this and this to be a single group, and the minterm for this Kmap will be equal to, from these 2 columns I have B bar as common, so B bar, and from this row I have C and D bar are common for both the ones. So this is the solution for this Kmap. Next, coming to other Kmaps, you can just group them in this way. If you have ones here, 2 ones and 1 1 here, then this both can be grouped, and also this can be grouped. See, if I don't take this one, I can also group only the single one over here, but if I group only the single one, the common terms for this will be A, B bar and C, D. So I'll get 4 literals in one minterm. But in case if I group this one, which was already repeated in the previous group, that is this green color group, the thing is I can reduce 1 literal. So in this case you have 3 ones. So if you have 2 ones here, I can group this, and after grouping this 2 ones, only this one will be left over. So if I group this one as a single one group, as a single one group, 1 literal will be more in my solution. So to reduce that literal, I'll take the help of other one which was already grouped in some other group. So you also get various number of possibilities for grouping 2 number of ones with the single number of ones. So if I have only one, I can group them. If I don't have single one, if I have somewhere else one, then I can take the help of some other one. First let's see this part. I have one here, so for this I can write my answer to be, this is what is common in this column AB. For this one AB is common, and for here C bar D. That means here I can write A, B, C bar D. This is the answer for this Kmap. And now coming to here. So here if I have one here, and for example just consider I also have somewhere else one here. So can I group this both? No, I can't group. I should individually take this to be separate group and this to be separate group. Now the answer for this can be, for this one, what are the common variables? You have A, B bar, C bar, D bar. That will be equal to A, B bar, C bar, D bar, plus this is another group now. So for another group, I have A, B and C bar D as common. That is A, B, C bar and D. So in this way I can group if I have single ones, and here also if I have a single one I can group here. The answer for this will be A bar, B bar, C bar, D bar, and here by grouping this single one I'll get A, B bar, C bar, D. Here I'll get A, B bar, C, D. Here I'll get AB, C bar, D. And here I'll be getting A bar, B bar, C bar, D bar.